Hello friends. So today we are going to discuss about the topic of the potential energy of a spring. Clear? To understand the basic concept of potential energy of a spring, let's take an example. In example, we have three different diagrams. We will discuss all the diagram one by one. Come to the first one, in which we have a light and a perfectly elastic spring. Light and perfectly elastic spring. One end of the spring is fixed to this side, and other end of the spring is fixed with a body or a block having mass m. Clear? And after that, we displaced the block from its mean position. That mean position is O. We try to displace the mean block from the mean position to the point P. That displacement we have considered as a x. As we stretch or displace the block, at the time restoring force act on its system, and that restoring force will be F directly proportional to the x. If we remove the proportionality, it comes out to be F equals to minus kx, where k is called as a spring constant and negative sign is highlighting the restoring force act in a opposite direction to the displacement. Clear? After that we want to calculate a work done during this system. What is the basic work done during the system? Here we need to understand one thing, that during the displacement of a block from mean position to any point, at the time whatever the force we are implementing, that is not a constant, that is varying force. That is a varying force, and it creates somewhere a difficulty to measure a work done during the varying force. So to avoid that problem, what we do, we make a small step of displacement. We consider a small displacement from point P to point Q as a small or very small displacement, which is simply called as a dx. If the displacement is very small, so at that time means force will remain constant. If displacement is very small, at the time it means force is very constant. So what will be the total work done? What will be the total work done at the time? Work done is W equals to Fs. So what will be the total work done for a small dx? That is W equals to Kx into dx. Kx into dx. Integrate for the entire system from lower limit to the upper limit. The lower limit will be 0 and upper limit is the maximum displacement. Consider the x as the maximum displacement. Clear? So lower limit will be 0, upper limit will be the x. Kx dx. K will be constant. Variable is only x. So at the time W come out to be half kx square. Half kx square. What it is? It is a work done of a system stored as a potential energy. Clear? Next if we want to study what will be the total energy of a system, means what will be the kinetic energy and what will be the potential energy. So we need to discuss all the things. So we need to draw one diagram between displacement and the energy. Clear? So when we draw a diagram between displacement along the x-axis and the energy along the y-axis, so what happened? To understand this diagram, we have to revert back to the figures. That is figure 1, that is mean position. We have displaced the block from mean position to some point. Assume we have displaced it to the maximum position, which is called as a P, and maximum displacement is the x. So what it means, during at point P, at the time potential energy of a system is maximum. It means the potential energy will be the maximum. So if it is maximum, extreme position are highlighting like this. As you going to leave the body from here, it returns back to its mean position. if the body is returning back from any point, like if you throw a ball to upward direction, when it is returning back at the point from where it is returning back, it is only possible when the kinetic energy of that particle is zero. Kinetic energy of the particle is zero. So same point, the P will be the maximum potential energy and kinetic energy at that point will be zero. As the body will be leaved, body will try to retain the point O, which is the origin, but body will not be stopped here. Body will not stop here. It come to the another end of the extreme position because due to the some energy. So means at the another side there will be second extreme position, again having a maximum kinetic energy. Corresponding again to that maximum energy, we have a zero kinetic energy. Come back to the mean position. When the block is at point P, when the block is compressed, crossing the point O, at that time spring is neither be compressed nor be elongated. So that means spring is in the original position. That means potential energy of the spring will be zero at point O. So which is highlighting like this, zero potential energy. But at the same time, the body is not stopped here due to its kinetic energy. So what it means? It having a maximum kinetic energy. Corresponding to that, kinetic energy is here. That is maximum. So that is the complete basic description for the plot for the potential energy and kinetic energy between displacement and the energy. Clear? So it also highlighting a law of conservation of the energy. Total energy of the system is always conserved. Clear? Hope whatever I have tried to deliver you, you have understand the concept, you have understand the things what I am trying to deliver you. If you like the video, hit on the subscribe button and one like please. Thank you very much. Have a nice day.